Hello everyone, welcome to week 8. This will be the last set of notes that we need to do, and our CPT will begin next week. Now, the CPT I will explain during our meet on Monday, but in the meantime, it is 2 sections left to go here, okay? So, 7.2, present value of an annuity. Let's see what happens. Okay, so this version pays out instead of collecting or paying in to make a pile. So 7.1, last week's version, you paid in a certain amount of money once a month, once a week, once a year, whichever, and you built it up to make it a big pile of money at the end. Present value of an annuity is different. Here, you put a chunk of money into the plan right off the bat, and it pays out. The easiest version to explain this with is the cash for life. This is how it works. So let's say you won, don't we all wish? And Cash for Life says they're going to pay you $1,000 every month for the rest of your life. Well, it's not the rest of your life, it's the first 25 years. Okay? The way it works, they don't pay you directly. They put a chunk of money into an account so that the account pays the complete 25 years. And there are companies lining up to do this for them. It's really quite ingenious when you think about it. So let's say they found a bank account that offers 4% compounded monthly. So they gave us a different version of the formula that we used before. Now, if you remember, the one that we used in 7.1, it was 1 plus I to the power of positive n. Here, that it's paying out its present value, you'll notice it kind of looks like the same formula with the exception that it's now 1 minus 1 plus I to the power of negative n. That's a minus in front of the n. Okay? So the negative means somebody is paying out from the plan. Positive n means you're paying into the plan. All right, let's keep going. So, present value, that's what it is worth today before the plan starts and goes for 25 years. All right, R is the payment, little I is the interest per payment, and N is the total number of payments. I'm a big believer, and I do mean big believer, of listing all the pieces here. When students have trouble, the only trouble they have is punching the right number in the right spot, because I give you the formula. So it's not like you got to go look for it. All you need to remember is, since this plan is paying out for the next 25 years, I need the version that has minus n. All right, let's keep going. So each payment is $1,000. The interest rate is what it is. Once I divide by 100 and then divide by the number of payments in a year. And then the total number of payments, 25 years times 12 per year, 300 payments. When I plug everything in, all right, notice I did the 1 plus I right off the bat. Saved myself a step. Then I did to the power of negative 300 in red. Then it's 1 minus that decimal, and that gives me this version. Now that I'm down to here, it's strictly 1,000 times this number, divide by that number, and it's $189,452.47. Now that seems like a lot of money, and it is. But what happens is the plan puts this into the bank account. The bank account starts paying out $1,000 every month. All right, so let's take a look at this. Ready? The interest, the amount of money that you are going to make, or should I say, the interest is the amount of money this plan saves the prize board. So interest, your payment times the number of payments minus the present value, which was $189,452.47. Watch this. All right, so when I crunch this, $1,000, 300 payments, you yourself are going to make or receive 300,000. The prize board was only 189,452.47. The plan is picking up 110,000 at 4% only. That means this plan helps them to pay off 1/3 of your prizes. So it's really quite ingenious in that they don't pay you the full 300,000 directly. You have to wait, and while you're waiting, the plan is making money for them. Hence, you get your 300,000, but they don't pay you 300,000. They're paying 2/3, and the bank, through interest, is paying the last third. Like I said, it was really quite ingenious. All right, so I did my explanation right there. Okay, let's keep going. Next example. All right. So your parents have retired. Sorry for the grammar error there. Your parents have retired. They want to put away money now so that it pays out $300 every month for the next 20 years. If the bank offers 6% per annum compounded monthly, how much will they need to invest? Your parents are going to lock away some money so that they get a check or addition to their funds to pay $300 every month for the next 20 years. Now, it could be anything. It could be the fact that they set up the money so that it covers the cost of gas and bridge heating all year long for the next 20 years, whatever it is. All right? So here's my setup again. And like I said before, I'm a big believer of listing this. That should be 1 mark just for that. Don't lose this mark. It's too easy. There's my present value system, and I know that it's paying out because of the minus n. Okay, the minus n. Well, once I finish crunching, I notice that my present value means I have to put away the $41,874.23 today in order to make this work. Interest, $300 for 240 payments total, right? 20 years. That's $72,000. Now look, at 6%, that's almost half that the bank is paying for your parents. All right? So this plan is a good one, depending where you are with your part of life. All things being said, first you need to get to work to make some money to set up the plan. Anyway, again, in number 13, I wrote it like this: treat Angela and Becky as separate stories so that you do 2 sets of equations to see which one's better. Again, I've shaved a lot of the homework, so you should do all of this. Thank you.